using -4 as one of the zeros. So when they give you the actual zero, like the fact that they give me it as -4 and not x minus 4, -4 goes on the outside. And then it would be 1, 8, 19, 12, bring down the 1, -4, 4, -16, 3, -12, 0. And because it's 0, I know at least that part's right. Then I've got to take what's left here, right? The 3 doesn't get anything. The 4 gets the x, and the 1 would get the x squared. So this would be x squared plus 4x plus 3. This actually said use the result to factor completely. I can keep factoring that into x plus 3 and x plus 1. And then list all the real zeros. This would be -3, -1, and the -4 that they gave you at the beginning. So you need all three. Yeah. You need all three. 9, same thing, but 1. Oh, so it's probably the same thing. Oh, no, you didn't put it. This is 1/2. Then on the outside, where the 1/2 goes on the outside, this is 2, -15, 31, -12. Bring down the 2. 2 times a half is 1, -14. 14 times a half is -7. 24 times a half is positive 12. Then I'd get 2x squared minus 14x plus 24. And again, I wanted you to factor it. You could take out a 2 this time, x squared minus 7x plus 12, make your life a little bit easier. And then it'd be 2x minus 3 and x minus 4. The 2 can never equal 0, so we eliminate that, but this is 3 and 4. So it's the 3, 4, and the 1/2 they gave you at the beginning. Richard?
Why can't the 3?
Because if you set that equal to 0, you can't solve it, right? Like if you took out a 2x, now you have another 0, and it's 0, right? Then 10, use the 0 or the root. So this is, we had to do this on the graphing utility. So I'm going to graph this on the app so it's easier. All right, so when you graph it, there's one recognizable whole number passing through the x-axis, which is here at 3. So I know 3 is at least the whole number root that I've got. The other ones, there's 2 other roots, but I can't tell what they are from the graph because they're not whole numbers. So the 3 goes on the outside and then goes 1, -3, -7, 21. Bring down the 1, 3, 0, 0, -7, -21. Again, the remainder should be 0. That's how I know I did that first part right. Now I got to take what's left. This would be x squared minus 7. It's not factorable, but I can solve it. If I set it equal to 0, I get x squared equals 7, square root both sides, and I get plus and minus the square root of 7. So those are the other 2 roots. Okay, this said you can do 3 decimal places on your test. It would be exact, so you would list them as 3, -√7, and +√7. And then if it wanted it in factored form, it's x minus each of those. So it's x minus 3, x minus a -7 becomes x plus 7, and then x minus 7, 7 would be the last one. I think that's what. The graph. It passed through 3. That's the only whole number it passed through. This one said, it said use the feature on the graphing utility to find it. Yeah, you could use the table or you could use the graph itself. Okay, so then 10. So this was, Sophia, this is yours. So you got the 2? Because you said just B and C. You got the 2, you put it on the outside? Yeah, and then 1, -2, -6, 12. Bring down the 1. 2, 0, 0, -6, -12, 0. X squared minus 6 was yours, right? Set that equal to 0. X squared would equal 6, and x would equal plus and minus the square root of 6. So the 3 zeros are the 2 you got from the graph, positive √6 and -√6. And then when you write them x minus, that's what it looks like. It's x minus 2, x minus √6, and x plus √6. That's what it meant by factored form. Same thing for 11. So from the graph, you get -3. -3 goes on the outside. Then it's 1, -3, -11, 21. Bring down the 1, -3, -6, positive 18, 7, -21, 0. And then I get x squared minus 6x plus 7. There are no factors of positive 7 that sum to -6. So this isn't factorable, which means you have to use the quadratic. So -6 would be 6 plus and minus the square root of -6 squared minus 4 times a times c all over 2 times a. 6 plus and minus the square root of 36 minus 28 over 2 6 plus and minus the square root of 8 over 2, which is 6 plus and minus 2 root 2 over 2, which becomes 3 plus and minus root 2. So in addition to the one you got from the graph, which is negative 3, your other roots are 3 minus root 2 and 3 plus root 2. Now this one's tricky to write out with the x minus because the minus has to get distributed to both. So it becomes x minus a negative 3, that's x plus 3, but then it becomes x minus 3 minus root 2 and x minus 3 plus root 2. This stays the same, but this gets distributed to both. So x minus 3 plus root 2 and x, this goes to both, minus 3 minus root 2. That would be in its complete factored form. B just said find the exact value of one of the zeros. You only needed one of them. That's all. And then C was the full thing. All right, this is 5. So 5 said, so this is your Sophie. Synthetic division. So I'm not missing anything. It's in order of decreasing degree. 6, 7, negative 1, 24. And on the outside goes a positive 3. Bring down the 6, multiply it, put it in the next column, add it. Look, you put negative. Positive, add it. Yep. Yep. Well, and maybe because that negative, because that changes that. So then it should have been.
Yeah, because when I was doing negative 1 and 75, I put negative 74.
I got you.
Yeah. Okay.
So 246. And then this is x squared. This is, x to the first. That's my remainder, right? X squared. It's interesting they put it in this order. It would be 6, I would do 6x squared plus 25x plus 74 plus 246 over x minus 3. I don't know why they do that in the middle. Good? So that practice of finding a root from your graphing calculator, like we're going to keep doing that. So just make sure you're comfortable doing that. All right, so 3, 4 is called zeros of the polynomial functions. It starts with that factor theorem again, remember, which says that if my remainder is 0, or if I took whatever the x value is and plugged it in and I got 0, then the divisor is a factor. So if it's asking is blank a factor, you're looking for the remainder to be 0. Okay, that's how we know something is a factor. So it says factor f of x equals 6x to the third plus 19x squared plus 2x minus 3 if x minus 3 is a factor. So I need this in complete factored form is the goal, and it's giving me one of the factors. Now here's what you want to pay attention to. What's the highest exponent on my original question? The exponent. 3, right? So how many parentheses should be there if it's completely factored? 3. There should be 3 factors, which means there's 3 parentheses. So if they give me 1, if they give me negative 3, I'm going to do negative 3 on the outside. I'm going to reduce it so that it's squared, and then I would factor what's left, or I find the remaining factors and then put it in those parentheses. But always think at the end, I should have that many zeros. Okay, I should have 3 zeros. So I'm going to put, this time it gives me x is equal to negative 3, not x minus 3. So it stays as negative 3. It goes on the outside. I take what's left, 6, 19, 2, and negative 3. It's in decreasing degree order. Nothing's missing. I bring down the 6. I multiply it by negative 3. Put it in the next column, add it. I get 1. Multiply by negative 3. Put it in the next column, add it. I get negative 1. Multiply what's on the outside. Put it on the next column, add it, and I get 0. This should always happen if it's telling you something's a factor. If the remainder is not 0, you did something wrong, and stop it and do it again. So I know negative 3 is one of my factors, right? Or one of my zeros. Now I have to take this, what's left, 6x squared plus x minus 1. I would check to see if it's factorable first. So I would do my first times last here. Is there 6 times negative 1 would be negative 6. Are there factors of negative 6 that sum to positive 1? What are they? 3 and negative 2. Replace the middle term with those 2. And then factor by grouping. So I can take out a 3x and I get x plus 1, 2x, sorry, plus 1. And I can take out a negative 1 and I get 2x plus 1. So 2x plus 1 and 3x minus 1. It wants it in complete factor form. So if it said list the zeros, my zeros would be -3, -1/2, and +1/3. I got that from the one they gave me. And then I would set each of these equal to 0. I'd get -1/2 here, and I'd get +1/3. So if it said list the zeros, that's what it would look like. Or solutions, or on a graph, these would be X intercepts. It wants you to put this in complete factored form, which means I'm going to do x minus each of those. X minus a -3 becomes +3. X minus a -1/2 becomes +1/2. And x minus 1/3 would stay as x minus 1/3. Now, we don't have fractions in our parentheses when we factor. So the last thing you're going to do is take anything that has a fraction and multiply, get rid of the bottom by multiplying the first term by its denominator. So to get rid of the 1/2, I multiply the x by 2. To get rid of the 1/3, I multiply the x by 3. So this is the format you want to be writing answers in. No fractions, no squareds. Everything should be completely factored. Yep.
So pretty much do we just like not factor like?
So if it just asked for factors, I could take from here and then just add on the one that they gave me. If it asks for zeros and the factors, then you want to list both. So this would be the format of one, and then this would be the format of the other.
Why did you flip the signs for the...
Because it's always x minus that. Think about it, when we take it out of the parentheses, we change the sign, right? So it's always x minus whatever the root is. So it's always going to change the sign. All right, so now notice the difference in the instructions. This first one said x equals -3 is a factor. This one says x minus 1 is a factor. How does that change my setup?
You take -1 and make it positive.
Good. I'm going to put a +1 on the outside. So I have to change it if it follows the x. If it was just x equals, I use it as it is. But because that says x minus 1, I have to change it so that it's a +1 on the outside. Then everything's in decreasing degree, nothing's missing, so I just list out my coefficients and my constant, and I bring down the 2, and I multiply it, put it in the next column, and I add it, and I multiply it, put it in the next column, and I add it, and I'm -6, and I multiply it, and I put it in the next column, and I add it. Again, last one should be 0 unless you do something wrong. Then -6 stays as the constant, the -1 gets the x, and the 2 gets the x squared. I end up with 2x squared minus x minus 6, and I want to see if it's factorable. So I multiply 2 times -6, I get -12. Are there factors of -12 that sum to -1?
3 and -4.
Good. -4 and 3, or 3 and -4. Replace the middle term with those. And then factor by grouping. Take out a 2x. Take out a +3, and I get x minus 2 and 2x plus 3. So I just have to add on the factor that they gave me in the beginning, because all this wants is a factored answer. If it had asked for the zeros or the roots or the x intercepts, it would be 1, 2, and -3/2. I don't remember what was they asked for. Yep.
So the zeros include the variable.
Right. If it says the words remaining zeros, then you only need what you find. If it says all the zeros or factored completely or anything like that, you're including all of them. All right, so we took -5, we put it on the outside, we reduced it the degree to get it to 6x squared minus 13x plus 2, and then that was factorable. The remaining factors were 6x minus 1 and x minus 2, so since it says factor, you're going to do it completely. 6x minus 1, and then x minus 2, and then x plus 5. Order there doesn't matter as long as the signs are with the right things. Questions on that?
It's not asking for a 0.
No, it just said factor. So when it wants it factored, you want it in that factored form.
How do we know if maybe you put it like
If it says list the zeros, list the roots or solutions, like those are the same things, that's where you list them by comma, separated out. If it says factor or put it in factored form or factor it completely, anything factor like that, that's when you put them all in that. All right, so what happens if you don't get given a head start? Like in all of the examples up to this point, we were able to use our graphing utility to find one root, or in those examples, they gave you a 0 to start with, right? What happens if you get nothing and it's not factorable? You do this. So you're going to find a list of possible zeros or possible roots. To do that, we make sure our polynomial is in order from largest to down to no x, so highest degree down to none. And then we list all the factors of the last term, which would be the constant, over all the factors of the first term. And this sets up a possible bank. So it's just possible that those roots are it. It doesn't mean everything in that bank works. Then we test, and it becomes so tedious and so fun to test all the roots until you find one that works. So you could have a bank of like 32 roots, and you've got to find the one that works. And this is where you get so much practice at synthetic division that you come a little bit faster at it. How would I know one works? Like, how do I know one is a 0? The remainder 0. So as soon as I go through synthetic division and I find one that gives me a remainder of 0, I found one root. If it's cubed, I only need one root because now it brings it to squared. And then from squared, it will either be factorable or I can use the quadratic. So I really only need to get one root if it's x cubed. Let's say it started as x to the 4th, and I find one root and it's still not factorable. I got to find a second one. And then I can do the quadratic, or I could factor it, okay? So that's what this says. You're going to find all your roots by testing the possibles. So you're going to set up your bank of possibles until you find the 0 that works, which would have a remainder of 0. And then continue until the quotient can be factored, or use the quadratic formula to find the remaining factors. In order to use the quadratic formula, the highest exponent has to be squared. You cannot use the quadratic formula on x to the 3rd. That's cubic. That's not quadratic, okay? So they'll look like this. It will literally just say find all the zeros. So if I look at 4, it's got 4 terms. Normally I would try to factor this by grouping it. But I cannot take out the same thing from 8 and 50 and 47 and 15. So this is where that possibles happens. I'm going to go look, make sure it's in order, which it is. I'm going to break down all the factors of the first term. So what are the factors of 8? What two numbers multiply together to give you 8? 1 and 8 and 4 and 2. Then I'm going to go to 15. I'm not worried about the sign because that comes at the end. I'm going to break it down into its factors. So what are the factors of 15? 1 and 15 and 3 and 5. Now it's last over first. So I have to take each of the 4 of the last ones and put them over each of the 4 of the first ones. So the first thing is it's plus and minus, which means the bank is positive version of the number and the negative version of the number. First, what I'm going to do is 1. I'm going to put 1 over each of these. So 1 goes over 1. Then 1 goes over 2. Then 1 goes over 4. Then 1 goes over 8. I see if I can simplify them, those stay as they are. Then I do 2. Then I do 3. 3 goes over 1. 3 goes over 2. 3 goes over 4. 3 goes over 8. Then I do 5. 5 goes over 1. 5 goes over 2. 5 goes over 4. 5 goes over 8. And then I do 15. 15 goes over 1, 15 goes over 2, 15 goes over 4, and 15 goes over 8. So when I list my possibles, it is positive and negative. So it's positive 1 and negative 1, positive 1/2 and negative 1/2, positive 1/4 and negative 1/4. You just don't have to write that every single time. So it's plus and minus 1, 1/2, 1/4, 1/8. 3, 3 halves, 3/4, 3/8. 5, 5 halves, 5/4, 5/8. 15, 15 halves. Oh, I crossed out the wrong one. 15/4 and 15/8. Now, if any of those repeated, like once I reduce them, I don't have to list them twice. I only need to list them once. So if I had like 1/2 happen twice, I only need it once. Okay? And you always want to make sure you can reduce them. I didn't cross them out. 5 halves, yeah. So that's the possibles. Now I got to find the actuals. Okay? I'm not telling you that you are never going to be able to avoid a fraction, but certainly when you're testing them at the beginning, I would try to see if a whole number works before I move on to the fractions. So I'm going to start synthetic division using -1. So -1 goes on the outside. 8, 50, 47, -15. I bring down the 8. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column. It's not going to be 0. So I go to 1. Bring down the 8. 8, 58, 58. No way this is going to be anywhere close. So I go to -2, or -3 would be the next whole number. 8, 50, 47, -15. 8, -24, 26, -78, 31, too big, go to 3. It's already getting to be too big, right? So you don't have to always go through with it. Now I go to the next whole number, which is 5. I'm going to go to -5. And hallelujah, -5 works. That's my first 0. Yeah. You need 3 of them. The good news is that we just took something that was raised to the 3rd power and reduced it a degree. So what's here, I can solve without having to keep going through roots. I can either factor this, or if it's not factorable, I can use the quadratic. You will always be able, if you can get it down to x squared, you're done with the possibles. Unless it was like x to the 4th, you're going to have to do it twice. Yeah. All right, so now I'd get 8 times -3, which is -24. Are there factors at -24 that sum to +10? Yeah, which ones? 12 and -2. 8x squared plus 12x minus 2x minus 3. And then factor by grouping. And I get -3 halves and +1/4. So it says find all the zeros, which means my answer is the -5, the -3 halves, and the +1/4. Some of the questions on WebAssign are going to say find the possibles and then find the one that works and then continue. Some of them are literally just going to say solve. And you have to know that that means you have to find the possible. If it's not factorable, which they're not going to be factorable, you're going to have to find the possible. Okay? So just keep that in mind. Almost every question's like that.
How many of those are going to do the test?
On the test, well, we haven't made it yet, but I would assume not a lot just because it takes so long to do this. I don't know. Don't quote me on anything. Yeah.
Will any of the all the whole numbers ever not work?
Yeah.
They have to do all the fractions?
Yeah, I think on the homework, you get at least one whole number every time, but like in the grand scheme of things, of course,
Wait, she's saying we have to test every single one of those points?
you would eventually, yeah. No, on the homework, there's a whole number on every single one.
So we have to test most of those points.
Yeah. So there's a hint. Start with the whole numbers on the homework because they'll be there.
So you don't have to put it in like the X
No, so if it hits that, put it in factored form, then it would be x plus 5, and then 2x plus 3, and then 4x minus 1. But because it says just find all the zeros, this is the format of the answer.
Can you switch something on the top?
Can what?
Can you switch something from the
Yeah.
thing? Like for a number,
I mean, the payoff is the possibles are easier, right? The factors of 6 are just 1 and 6 and 2 and 3, and then 2 is just 1 and 2. So I have to do plus and minus 1 over 1, 1 over 2, 1 over 3, 1 over 6. None of those reduce. And then I have to do 2 over 1, that's 2. 2 over 2 is 1, and we already have it. 2/3. And then 2 over 6 is 1/3, and we already have it. So there's my possible bank. You good so far? Good news is there's only 4 whole numbers to try, right? So I start with -1. I get 6, 7, -12, -3, 2. Bring down the 6, -6, 1, -1, -13, +13, +10, -10. Doesn't work. Go to +1. 6, 7, -12, -3, 2. Bring down the 6, 13, 1, -2, and 0. There's the first one. 6x, this would get x, x squared, x to the 3rd. That's my remainder. If I could factor this by grouping, I could do it that way, but you can't, which means you have to find another root. Now here's what you want to do, so listen carefully. You don't want to go through the roots from the beginning again. You can now test the roots out on your reduced one. So I can take these numbers, 6, 13, 1, and -2, and test those out with my remaining roots. So I already did 1 and -1. Now I would try -2, bring down the 6, -12, 1, -2, -1, 2, and there's my second one that works. And now I just reduce this to the point that it is squared. If it is squared, it will either be factorable or I could use the quadratic. So my goal is just to get it squared. So I get 6x squared plus x minus 1, factors of -6 that sum to +1, 3 and -2, 6x squared plus 3x minus 2x minus 1, and then we factor by grouping. Take out a 3x. Take out a -1, 2x plus 1, and 3x minus 1 means my remaining factors are -1/2 and +1/3.
so if it's cubed, you don't have to worry about it.
So if it's cubed, you're going to find, you got to keep going.
I don't think it's squared.
Yep. So I found 1, -2, -1/2, and +1/3.
On the test, we'll just show this is yours, or we'll show the top.
I'm assuming we're going to have both things on there. So you're going to have that, and then you're going to have to write it in factored form.
The X.
It would be x minus 1, x, I wrote minus 1, x plus 2, x plus 1/2, which I'm going to have to get rid of, x minus 1/3. So I get x minus 1, x plus 2, 2x plus 1, and 3x minus 1. That's how it would look if it was in its factored form. But the directions, just pay attention. On the homework, it goes flip-flop between them. The first ones literally say find the rational zeros, and then when you get to number 8, that's when it gives you, it says find the possible zeros, and then it starts to involve the graph calculator, determine all the zeros. Not till it gets to number 10 do you have to write it as factored form. So the last 2, you'll write it as factored form. Questions? Yeah. So good question, good segue. Okay, so if I wanted to how does this overlap onto a graphing utility? Think about what happens. What does a 0 look like on your graph? How do you identify a 0 from a graph? It's when it hits the x-axis. So if I took this function that I just solved and I type it into my graphing utility. So if you haven't practiced your graphing utility and you have it with you, do it. Even if you have, do it, because you're gonna obviously want to be comfortable. You don't want the graphing utility to be the reason that you struggle on a test. So I typed it in. All right, so I typed it in. It looked like this. 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. And then I hit graph, and there's the graph, okay? It's cut off on the bottom. Eventually, we're going to learn how to get all the way down there. But for right now, what we want to pay attention to is the X intercepts, right? If I go to table, so above graph, second graph, and I go to table, everywhere it crosses through the X axis, that's a whole number. It's going to show me on that table. So already from this, I see that it's happening at -2 and it's happening at +1. What you don't see is all the decimals in between, okay? So if I needed to get those from the graph, I'm going to go back to the graph. Let's say I want to get this first 0 on the left. I go second, trace, and I go to 0. I hit enter. It's asking me to go left of that 0. So I'm going to go left all the way till I pass the 0. It could be there. It could be, nope, that's it. It's got to be left of it. That's all. I hit enter. Now it wants me to go right of it. So I hit the right arrow. I'm now to the right of the graph. I'm below it, but I'm also to the right of it. I hit enter, and then it says, are you ready for me to guess? I say yes, and I hit enter, and it brings me to -2. Now there's 4 zeros here. So if I want to do it again, I go second, trace. I go to 0. I'm going to go now to the left of the next one, which means I have to bring it all the way up here. I hit enter, and I have to go past it, but I can't go so far past it. I go to the next 0. So I'm going to stop here, and then I hit enter, and there's my second 0, -0.5, which was that -1/2 we got. Second, trace 0 again. Now I want to go left of the next 0. Anywhere here is fine. I want to go right of the next 0, but not past that last 0. So here, guess, and it brings me to that one, 0.3333, which is 1/3, which is the other 0 we got. And then the last one, we already know because that was that whole number, but I'm left of it. Oops, nope, sorry, let me do it again. 0. I have to go left of it, but past the one on the that I just got left, and I have to go past it so that's on the right, and then guess, and it brings me to that 1, which is our last 0. Yeah.
So on the test, if we want to avoid all that work, can we do that? Or can we just
So what I'm assuming, remember we haven't made it yet, but I'm assuming, based on the prior knowledge, what will happen on your test is that there will be one real 0 that would be a whole number that you'll be able to find from your graph. And then you'll use that to reduce it a degree, and then you'll find the other ones. They won't be exact like that. They won't be a 0.33 that you could make 1/3. They would be a number that doesn't end and doesn't repeat, like maybe a square root. So you'll be able to find a root from your graph 1, and then you'll reduce it a degree using synthetic division, and then you'll take what's left and either use the quadratic formula or like it'll be a factorable, something like that. But it most likely will not be like a 0.5 where you could find it from your graph. Does that make sense? Yeah. That's what I think that the question, if I could predict what it will be, that's what it would be. Questions on what we talked about so far, because I'm going to stop there. We'll do the rest of those problems tomorrow, okay? I'm going to open up your homework. You can start it tonight. If you didn't finish 3-3, like if you didn't submit it onto Canvas, make sure you do that tonight and put a note for me. Hey, dummy, you forgot. Don't do that. Hi, Mrs. Chris Weiser. Remember you so kindly said that you screwed up and that you could give us another day. That's fine, okay? And then make sure you start the 3-4. So tomorrow you can come in with questions so I can answer those before I send you away for the break with the homework for 3-4. Okay.